This is the fifth and final part of our spring final exam review. This focuses a lot on growth, decay, logs, all that stuff that we've done in this past month and a half or so. So number one, you start an account with $500 and an interest rate of 6% compounded yearly. And there's your and right here are your formulas for growth and decay. On the final, if you need to use those formulas, we will give them to you, but you do need to know which one's which. The one with the plus sign is growth. The one with the minus sign is decay. Now, we start with $500 and we have an interest rate of 6% compounded yearly. If I have an interest rate, that means the value of my account is going up. In that case, we're going to use this formula for growth. Is this function exponential growth or decay? It is growth. Identify the initial amount. Our initial amount says right here, we start with $500. So our initial amount is 500. The growth or decay factor is the percentage expressed as a decimal. How do we do that? Anytime I have a percentage, in order to turn it into a decimal, I move the decimal over 2 places. It's always 2 places no matter how many numbers are here. If you have an extra spot, plug in a 0. So our growth factor for this one will be 0.06. Write an exponential function to model this situation. So for the model, we have f of x equals a is always our initial value, so 500. 1 plus r is our growth or decay factor, so we get 1 plus 0.06x. Anytime you see model, that means this type of equation. Now, how much is the account after 3 years? So let's take a look at this problem. We have 2 variables going on. We have time and we have money. We need to figure out which one is x, which one is y. Pretty much always time is going to be x. The other variable will be y. So if I see 3 years, I need to plug that in because it's time. We plug it in for x. So we get 500 times 1. It is 1.06, but we haven't added that yet. Plus 0.06 to the 3rd power. We plug all that in the calculator, we'll get 595.51, and that's our answer. Letter F, rounded to the nearest hundredth, how many years will it take for the dollar amount in the account to reach 3,000? So now it's asking how many years. We know time is x, so we're going to leave x in our equation. We still have 500. And how long will it take to reach $3,000? So that is our ending value. To solve this, we are going to try to get the base and exponent by itself and use logs. Here's how we do that. We will, and by base and exponent by itself, I mean this piece right here. That's what we're trying to get all alone. So we'll divide the 500 away. We get 6 equals, and then this piece, because it's in parentheses, we can do what it says. So add 1 plus 0.06 is 1.06 to the x power. From here, in order to solve it, we're going to log it. Anytime I have x in the exponent, and that's what I'm trying to solve, we have to use logs. So we could use our Snell method, which if we're going to use Snell method, we're used to this piece being on the left side of the equation. We're not so much used to it being on the right side. So what I could very easily do is move this equals 6 over to here. Now my base and exponent is on the left side. And so when I log it, I could use the Snell method. So I get log little 1.06, follow our snail around of big 6 equals, follow it around to x. We punch this piece in the calculator, we get x equals 30.75. Because it says nearest hundredth, that's 2 decimal places. So this is our final answer, x equals 30.75. Let me erase some of this so we could see our next question. From 2000 to 2010, a city had a 2.5% annual decrease in population. If the city had 2,950,000 people in 2000, find the following information. And then it gives you the formulas. So it's saying the population is decreasing. If I am decreasing, that means I am decaying and need to use this formula. Is this growth or decay? It is decay. Write the initial amount. It has an initial amount of 2,950,000 people. Identify the growth decay or the growth or decay factor. In this case, that's our percentage of change right there. So if I do 2.5%, move the decimal over twice, our factor is 0.025. Write the exponential function to model the situation. We'll do f of x equals 2,950,000. 1 minus 0.025 to the x. What is the city's population in the year 2008? Now I see a lot of people for this one to put 2008 in for x. That is not how we do that. What we need to do is, notice we start in the year 2000, and then x represents number of years. So to get from the year 2000 to 2008, we've only gone 8 years. So that's what's going to be what we plug in for x. So we'll get plug this whole equation into the calculator. We'll get scientific notation, but what it means is you would probably see in the calculator 2.40912 E6. What E6 means is move the decimal place over 6 times. 1, 2, 3, 4, 5. Then one more, so fill in a 0. And during what year is the city's population projected to fall below 2 million people? So the number of people is our y value, so we're going to plug 2 million in for y. And we're solving for x. Again, step 1 is get base and exponent by itself. So I'll divide that away. We'll get 0.677966 equals, and then when we do this part inside parentheses, we'll get 0.957 to the x power. From here, we're going to log it. Again, if you want to put this over on this side and do the Snell method, that's perfectly fine. So when we log it, we'll get log 0.957 of 0.677966 equals x, we'll get x equals 15. And so if we started in the year 2000 and it's taken 15 years, we need to add on 15 years. Our final answer is the year 2015. That's our final answer, the year 2015. And that's how you do these word problems with logarithms. You may not be asked A, B, C, D, E, and F, but you will definitely see questions like E and F on the final exam. You'll see questions just like that. So number 3, we're working with exponentials. X is in an exponent. So we're looking at number 3, and the first thing it's asking for is transformations. So the transformations of this this function right here, we should notice that 2 to the x is a parent function. That's not a transformation, that's our parent function. Just like x squared is a parent function we've worked with, square root of x is a parent function we've worked with. Way back in the first semester, we did absolute value of x as a parent function. So that's not a transformation. That's just our beginning. This -5 out here, remember anything outside is a y transformation, so that -5 means shift down 5. Notice in the exponent I have x plus 5. The exponent is going to be my x transformations. So that says x plus 5. We know x is lie, so it's a shift left 5. When it comes to exponentials, our asymptote is always our up or down shift. So in this case, it'll be y equals -5. And when x is in the exponent, it's always a y equals transformation. So that means our asymptote is right about there. On the x side, we'll put -5. On the y side, we'll put -5 also. So we get -5, -4, -4, -3. The point -5, -4. The point -4, -3 means that my graph looks something like that. Which you notice we're giving you the parent function points here. Obviously, this is a multiple choice test. You will not have to graph anything on your own, but you may see which graph represents this function, something along those lines. Or what is the asymptote of the graph? Let's look at the domain. Domain, we know we read left to right. It's going all the way to the left, and it's going all the way to the right. So our domain is all real numbers. Set notation is that squiggly line. We could put -infinity, less than x, less than infinity. Interval notation, -infinity to infinity. Inequality, -infinity to infinity. All these are different ways of saying all real numbers. Make sure you know the difference between set notation, interval, and inequality. You'll be asked about the difference on the final. Letter C, where it says range. Range we read down to up. So how far down does this go? It's stopping at 5. It's not going lower than that, but it does go all the way up to positive infinity. So our range would be -5 to infinity. In interval notation, it's -5 to infinity. In inequality, it's -5 to infinity. The x-intercept, this is the one where we punch the graph in the calculator, hit menu, 6 for analyze graph, and then option 1 for 0. Then notice our x-intercept is here, although it'd be more accurate on the calculator graph. It'll give you a dotted line. What we need to do is click once to the left of that intercept and then once to the right of it, and the calculator will actually give you the intercept. In this case, it is negative 2.68, 0. For the y-intercept, we do Control, then T. To get the table, we go to where x is 0. When we see x being 0, we see that y is 27, so our y-intercept is 0, 27. And that's it for number 3 here. Jumping down to number 4. Now we have a different parent function. The last one was 2 to the x. This one is 1/10 to the x. That's the parent function here. So first, let's list the transformations. We have that negative 2. That negative means reflect over x-axis. That takes care of the negative. The 2 means vertical stretch by 2. The plus 5 means shift up 5. And then that's it for the y transformations. Remember, the x transformations are the exponent. That plus 3 means x is live, so shift left 3. Asymptote, again, when x is in the exponent, we use our up or down shift, and it's always y equals, so y equals 5 in this case. That is our asymptote, y equals 5. Our graph cannot touch or cross that line. On the x side, we'll do minus 3 because of that lying x. On the y side, we'll do times negative 2, then plus 5. We will get negative 3 and negative 4. We'll get negative 2, negative 20, and 3, negative 15. So we get the graph negative 3, 3, negative 4, 15, so somewhere around there, meaning our graph is going to go that direction. Look at the domain. Just because it's going down doesn't, it's still going to the left as it goes down. So it'll be negative infinity, and then it's going all the way to the right, so to positive infinity. Interval notation, inequality. So we should notice whenever x is in the exponent, our domain will be some sort of variation of all real numbers. It's just how do we write it? For range, notice it's going all the way down, which is negative infinity. It's coming up and stopping at 5. So we get negative infinity to 5. Or for interval notation, still negative infinity to 5. Inequality, negative infinity to 5. X-intercept, again, we graph our function exactly as it is. Make sure we typed it in exactly right. That seems to be the biggest problem, is just some people missing parts of it. We do menu, then 6, then 1. That gives us that dotted line. Click once to the left of the x-intercept, once to the right. We see the x-intercept right there, so our first click is to the left, our second click is to the right. It'll give us the point 0, comma, negative 4.998. I'm sorry, it gives us the point. I'm sorry, I'm looking at the wrong point. That gives us the point negative 3.40, comma 0. For the y-intercept, we do Control, then T. Look at the table, go to where x is 0. We get the point 0, 4.998. That's the one I was looking at. So that's it for 4. 3 and 4, again, focus on where x is in the exponent. When we move on to number 5 and 6, which we will right now, it is different because now x is not in the exponent. We have logarithms, so that's going to change some stuff. So for logarithms, the parent function is the log, the x, and if there's parentheses here, that goes with the log little number and x are the parent function. So first we'll do the y transformations. Again, that's always the multiplier out front, the adder or subtractor in back. And then from there, we will get our transformations for y. So those transformations are a reflection over the x-axis. That's that negative out there. The 3 is a vertical stretch by 3. That plus 1 is a shift up 1. And so there are no horizontal transformations on this. The way horizontal transformations look would be if I had this would be an example of a horizontal transformation inside the parentheses with the log. Here there is no parentheses, so there is no horizontal transformation. So when it comes to logs, our asymptote is always our left or right shift. In this case, there is no left or right shift, so the asymptote is x equals 0. Notice our asymptote now is an x equals. When x was in the exponent, it was a y equals transformation, but now that it's log, it's an x equals transformation. X equals transformations are, or the x equals asymptotes are vertical lines. So there's our asymptote. Let's fill out the table. I gave you the parent function points already, so we will times negative 3 on the y side, plus 1. Nothing to put on the x side because there's nothing inside parentheses. So we'll get 0, then 2. We'll get, I'm sorry, 0, then 1. We'll get negative 3, then negative 2. And then negative 6 and negative 5. So I'll graph the points 1, 1, 2, negative 2, and 4, negative 5. So my graph is right about there. X-intercept still works the same way. Graph it, menu, then 6, then 1, click left, then click right. In this case, our x-intercept you'll see is 1.26, 0. The y-intercept, take a real good look at this. Notice our asymptote is right here on the x-axis. We know that asymptotes can't touch or cross an asymptote. It just gets really close to it. So if that asymptote's on the y-axis and we're not going to touch it, then there is no y-intercept. So let's go into domain and range. Domain, we read left to right. It's not over here. The domain doesn't start there. Notice the domain starts at the asymptote and goes that way. So our domain is 0 to infinity. Interval notation, it's 0 to infinity. And inequality, it's 0 to infinity. That's a little tip for logs. Your domain will always be your asymptote to infinity. That will always be your domain for logarithms. Now for range, we read range again from downside to upside. This is going all the way down to negative infinity. And then goes up to positive infinity. So negative infinity to positive infinity, negative infinity. For logarithms, the range will always be all real numbers. Not the same as problems 3 and 4 when we had exponents, x and the exponents. Remember when to use which type of domain, which type of range. But that's it for number 5. Again, feel free to ask more questions on this in class if you need me to demonstrate any of the calculator stuff. Smartboard's off. Okay. Number 6, we have ln. ln works exactly the same as logs. Only difference is the little number is e. We don't put the e because we know it's already there, very similar to how we don't put a 1 in front of x because we know it's already there. And we also know that the value of e is roughly 2.72. E is approximately 2.72. Kind of like pi is 3.14, but that's just rounded off. So the transformations are going to work exactly the same. That negative in front is still a reflection over the x axis. The 2 is a vertical stretch 2. That plus 2 is a shift up 2. And now we go inside the parentheses for our x transformations. That plus 1, x is lie, so it's a shift left 1. So let's find our asymptote next. Remember, from number 5, I said our asymptote is always our left or right shift. If I shifted left 1, my asymptote is x equals negative 1. So the asymptote on ln works the same way as an asymptote on log. It's x equals your left or right shift. In this case, it's right there. Next, we can fill out the table. On the x side, we'll have minus 1. The y side will be times negative 2 and plus 2. In my class, we use the points. Instead of these points, we use the points 2.721 for e, for ln, because that's the value of e. For the sake of this exercise, we'll use the points that are already here. However, on the test, feel free to use that point 2.72 for x and 1 for y. So we do minus 1, we get 0 to 4. Here we'll get 0, negative 2.2, negative 3.2. Then plus 2 is 2, negative 0.2, negative 1.2. So we get the point 0.2 to negative 0.2, so just below the x-axis. 4, negative 1.2, so just below 1. And we get our graph about there. Domain, like I said earlier, is always from your asymptote to positive infinity when it comes to logs. That's any log situation. And of course, log situations also include ln. So it's going from, in this case, -1 out to infinity. Sorry, domain is obviously x. So -1 to infinity. Then in interval notation, it's -1 to infinity. In inequality, -1 less than x less than infinity. For range, again, for logs or ln, it's always all real numbers. So y -infinity less than y less than infinity. Interval is -infinity to positive infinity. Inequality is -infinity less than y less than infinity. I know I've said this a lot in the other videos, but again, make sure you know the difference between set notation, interval, and inequality. It makes a big difference when I ask you for a specific version of the domain or range. X-intercept, once again, we graph it first of all. We punch that in the graph, then we do menu, then 6, then 1, click left, then click right. I apologize, I put those dots in the wrong spot. You saw the menu 6-1. Notice our x-intercept is right about there, so we'll click once to the left of it, once to the right of it. It will give us the point 1.72, 0. Y-intercept, we do Control T. Hit the table where x is 0, we get the point 0, 2 in this case. And that's how you graph using ln. It's exactly, and do the attributes, it's exactly the same thing as log. Moving on to the back page, again, hit pause if you need to get the rest of this down. But we're going to move on to the back page. Number 7 and 8 are inverses. We need to find the inverse. Now, in order to find the inverse, step 1, just like all the other inverses we've done this year, is to flip x and y. So we get x equals 10, y plus 1 minus 3. Step 2 is to get base and exponent all by itself. So in this case, we're going to do that by adding 3. Now that the base and exponent is by itself, there's nothing else there. We're going to log it. Once again, we're going to use Snell method. If you cannot see right away how to use the Snell method, base and exponent has to be on the left side of our equation. So we can put x plus 3 on this side, and the equals x plus 3 rather. And with that, we can do our Snell method. So remember, exponent should always be on the left side of the equal sign. So we get log 10 of x plus 3 equals y plus 1. When you put this log piece here, if you have two pieces that come, if you have couple pieces that come as a package deal in this section, put them in parentheses. That way you don't mess up your order of operations later. And then our last step is to get y by itself. To do that, we'll do minus 1. So we'll get, as our final answer, log base 10 of x plus 3 minus 1 equals y. The other way you could see this written is -1 plus log 10 x plus 3 equals y. All I did was take that -1, move it over here. The other thing you may see on multiple choice tests, because that's log 10, we don't need to actually put that log 10. We could take it out completely. Why is that? Because when there is no little guy on log, we know in that section right there, let me write this a little bit better for you. When there is no little guy here on a log, we assume that it is 10. Sorry. We assume that that little guy is 10 if there is no little guy, anytime there's a log. And so these are two different ways to write the final answer. Again, this is going to be a multiple choice test, so you need to be ready for either one of those to be presented to you, and whichever way you see it is the right answer. You'll see one of them, not both of them. So pause this if you need to. I'm about to erase this to give me some room to do number 8. So number 8, once again, we're doing an inverse, but instead of starting with an exponent like we did in number 7, I'm starting with a log. Now, if I'm going to start with a log, just like before when we got base and exponent by itself, I want to get the log by itself. To do that, well, first off, we're going to switch x and y. To get this log by itself, the first thing I'll do is move that 4 over. Now be careful, it looks like the log is by itself, but it's not because of that negative. We need to get rid of that negative. So I'm going to divide by -1. And when I divide by -1 on this side, all it's going to do is change the sign. So I get -x plus 4 equals log. Sorry, that should have been a y up here too. We get log y minus 3. So at this point, we've gotten the log by itself. This is when we need to convert it. Again, when we want to convert it, just like exponentials, we want the log on the left side of our equation. So to do that, we'll move the -x plus 4 over to this side. Now I can do my Snell method. Once again, just like before, if there's no little guy on the log, we assume it's 10. So I get 10 to the -x plus 4 equals y minus 3. Last step is plus 3. I get 10 to the -x plus 4 plus 3 equals y. This is our final answer. The other way you could see this written would be 3 plus 10 to the -x plus 4 equals y. Both of these are acceptable ways to write the answer. You could potentially see either one. I just want to point out real quickly a common mistake that I've been seeing that I want to make sure you guys don't make. In this problem right here, we had x minus 3 equals 10, y plus 1. A very common mistake that I don't want you to make is to divide by 10 right here and then try to cancel that out. That does not work. The only way to get an exponent by itself is to log. So make sure we don't make that mistake. Nine, 10, and 11, we're converting from exponential to logarithmic. We can use the Snell method here. So there's our roadmap. We get log little x of 101 equals y. Number 10, again, Snell method. We get log little 1 over 6, big 1 over 216 equals 3. Whenever you see a fraction, put parentheses around it. Not that you would necessarily be wrong without it, but there are times where you would be wrong without it, and you'll always be right with it. You're always safer just to put parentheses around a fraction. Number 11, we get log 14 of 196 equals 2. And that's how you do that. Number 12 to 14, we're still doing logs, converting, but we're converting starting with the log and trying to go to exponential. Snell method still works. We circle the first number we see, which is the little one. In this case, we get 9 to the -2 equals 1 over 81. 13, we do y to the x power equals 76. Number 14, notice there's no number here, so we do 10 to the y equals x. Once again, if we don't see anything, we assume that it's 10. I'm going to add another problem here. If I had ln x equals 6. Just like log, when there's no number, we assume it's 10. For ln, if there's no number, we assume it's e. So when I do the Snell method, I get e to the 6 equals x. I just wanted you to see the one with ln because it's not on the review, but I wanted to make sure you have it. Because that will make a difference come solving in a couple problems from now. Number 15 through 17, evaluating. These are very, very easy to evaluate. We just punch them straight into the calculator as they are. Log little 4 of 1 over 16 equals 1 over 81. Just punch that straight in the calculator part, not the graph, the actual calculator part. Then number 16, log base 6 of 36 equals 2. And number 17, log of 1,000 equals 3. This may be a time you want to pause if you want to. I know these problems are easy, but just to practice making sure you know how to put these logs in the calculator and get the correct answer, because on the final exam I cannot help you punch stuff in the calculator. So although it seems easy, make sure you know what you're doing. Number 18, we're starting to solve it using logarithms, solving logarithm equations. The first scenario we see is a log on both sides of the equal sign. When we have a log on both sides of the equal sign and the little number's the same, in this case they're both 2, all we have to do is cancel out the logs. Those two logs cancel each other out. I get x squared minus 1 equals 8. And we've seen in a couple of the other review sections, when I have x squared at this point in the solving process, the rules change, and instead of just solving for x, I'm going to move everything over to one side and set it equal to 0. So I get x squared minus 9 equals 0. And to solve an x squared, we need to factor in some way, shape, or form. X squared minus 9, I have two perfect squares. X squared and 9 are both perfect squares. And I have that minus sign, so that tells me this is a difference of perfect squares. If you need more help on that, please refer to part 2 of these review videos. That first page is all factoring, where I go very in depth on how to factor each type of problem. So this will the square root of x squared is x. The square root of 9 is 3. So we put a plus sign and a minus sign equals 0. Solve it from here. Set them both equal to 0. And then solve. So we get x equals negative 3 and x equals 3. So two different things going on in this problem, the log on both sides and the x squared. Those really don't have anything to do with each other. You could see x squared in any type of problem. It just happened to be in this one. You could see it in the scenario like 19 or 20 that we're about to do. You just did. But in this case, we saw it here. Be ready for that x squared to pop up in any scenario. So again, pause this if you need to. I'm going to erase this to give myself room to do number 19. Number 19, just like when we were doing inverse, if I'm solving and there's only one log in our equation, step 1 is going to be get the log by itself. So that means log, little guy, parentheses. Nothing else. If there's anything else on that side of the equal sign, we're going to move it over first. In this case, there's nothing else, so we're going to go straight into converting. So I get 5 squared equals 4x plus 11. 5 squared, as we know, is 25, so 25 equals 4x plus 11. And from here, it's just your basic two-step equation to solve for x. So minus 11, I get 14 equals 4x. Divide by 4, divide by 4. X equals, that'll reduce to 7 over 2. And that's how you do number 19. Number 20, once again, same idea. Get the ln by itself. In this case, it already is. And once again, if the little guy on ln, if we don't see it, is e. So when I do the Snell method, I get e to the third power equals 6x minus 5. E to the third power is 20.0855 equals 6x minus 5. And once again, same idea, two-step equation. So plus 5, I get 25.0855 equals 6x. Divide the 6 away, we get x equals approximately 4.18. And that's our final answer. So with the exception of number 18 in this scenario where they cross out, basically anything you do in this section, you'll have to either convert to a log from you'll either have to go exponential to log by converting, or exponential to log by converting, or log to exponential. You're going to have to do one or the other. There's no way to avoid that, and that does not work in the calculator. You just have to know how to do that. So number 21 to 23 is the same idea as the last three we just did, but instead of starting in a log, we're going to start in exponential. Step one is that exponential I circled, get that by itself. We can't convert until that base and exponent is by itself. So to do that, we will add 2. 3x equals 14. Or 3 to the x, rather. From here, again, the common mistake I'm going to see is to divide by 3 on both sides. That's not how it works. We need to log it. So I get log little 3 of 14 equals x, and x equals 2.402. And that's how you do that. Number 22, anytime you see e, the e has to be by itself before you convert. So in order to convert this, first thing I'm going to do is divide the 6 away. I get e to the negative 10r equals 21 over 2. Now that I got e by itself, I can convert it. We should know by now that anytime we see e, it's going to be ln. So ln of e, and remember we don't have to put the little e, but 21 over 2 equals negative 10r. In the calculator, it doesn't even give you the option to put the e because it's already there. So when you punch this in the calculator, you won't put the e. You'll just put ln of 21 over 2, which ln of 21 over 2 would be 2.35-ish, so that equals negative 10r. Last step is divide by negative 10. R equals negative 0.235. And that's your final answer there. So I'll give you a second to pause it in case you need to, but I need to erase this to have room to work on 23. Number 23, as I said on number 22, if I see e, that has to be what I get by itself. So step one is to get that by itself. We're going to do that by first subtracting 1. Why do I subtract 1 instead of dividing by 1? It's separated by that minus sign. If it's separated by a plus or minus, you need to add or subtract to get rid of it. So I get negative 2e to the 2x equals negative 20. Then divide away the negative 2. I get e to the 2x equals 10. And at this point, this is where I convert it. I get ln. Once again, we do not need the little e. ln of 10 equals 2x. ln of 10 we can punch in the calculator. We get approximately 2.30-ish equals 2x. Divide by 2, divide by 2, x equals 1.15. And that's our final answer. So that's how we do solving in basic problems. Number 24, still solving, but we are using word problems. Notice we give you the formula A equals PERT. We use that when our word problem has the word continuously. So Joni invests $5,000 at an interest rate of 5% per year compounded continuously. How much time will it take for the value of the investment to quadruple? So we're going to start out by plugging it into our formula. And real quick, let's just go over what the formula is. P is our initial value. So we'll start off with that. E is, well, E. We know that E is approximately 2.72, but our calculator does that part for us. R is our growth factor or decay factor. So 5%, we move the decimal over twice, we get 0.05 when we get rid of the percent. So 0.05 t. T is time, and A is our final value. So it's asking how much time, so how much time means we're solving for t, will it take for our investment to quadruple? So we started at 5,000. We need to figure out how long it's going to take to quadruple. Quadruple means times by 4. Quadruple means times by 4. So we get 20,000. We want to figure out how long it takes to turn this into $20,000. So to do that, just like solving one of these guys, step 1 is get the E by itself. So divide by 5,000. We get 4 equals E to the 0.05 t. At this point, we will log it, or because it's E, we will use ln. Snail method, like I've been saying earlier, base and exponent, we're more comfortable on the left side. So if you cannot log it from here, because you're unsure of it, move that equals 4 over to this side so you could use the snail method. We get e to the 4th power equals 0.05 t. I apologize, we get ln of 4 equals 0.05 t. And then ln of 4, punch that in the calculator. We get, stand by, ln of 4 is 1.38629 equals 0.05 t. And we divide by 0.05. T equals 27.73. So that means 27.73 years. So this is that is the end of our review on logs and ln and solving them and inverse and anything else you may see with them, word problems. Otherwise, this is also the end of our final review as a whole. So make sure you go back and rewatch any of these videos that you either need a refresher on or need to reteach yourself. Obviously, we have very few class periods left, or depending on when you watch this, no class periods left. So feel free to ask me questions on Remind. However, I'd like for you to refer to these videos, go back, watch what you need to, get yourself ready for this final. Everything on the final is somewhere in these 5 review packets. Thank you, and I've enjoyed having you guys very much this year. Hope you guys have a great summer.